Hi, I'm Travis and I'm an engineer on the academic team here at National Instruments. And today I want to show you a new approach to teaching sensor fundamentals in circuits and instrumentation courses. As you know, taking measurements of the outside world and making decisions based on those measurements is essential to almost all applications, including artificially intelligent robots, aviation, and telecommunications. In their careers, students will need to be able to interact with many sensors and will need practical experience to be able to accurately decipher relevant data. However, when they see equation after equation, students can miss out on practical knowledge of how a computer gets information from sensors and how to analyze that data. That's why a hands-on experience in connecting sensors and collecting raw voltage and applying an equation to get usable data is necessary to give students experience of the full measurement path, from sensor to software to solution. So let's get started. So here I have a thermistor wired in a voltage divider connected to my measurement device. In this case, I'm using a MIDAC. Now, a thermistor is a resistive sensor whose resistance changes with temperature. And the raw voltage I'm collecting is being processed in a program where I could apply the Steinhart-Hart equation to get temperature data. In this case, I'm using LabVIEW. When I run the code, I can see the temperature of the room. Okay. Now let's take the temperature of some ice water. Now, it should only be a few degrees Celsius. And perfect. Now I'm going to switch the circuit connected to the MIDAC from the thermistor to a load cell. Now a load cell needs a Wheatstone bridge to work, and in this case, I'm just going to use another load cell. Now back in LabVIEW, I can use the same program, but apply a different equation to get force instead of temperature. For this, I use a two-point linear equation. Now, when I put a known weight on my load cell, looks like I get a reasonable reading. So here I just collected raw voltage from two sensors and then dynamically applied the proper scaling equations to get usable data. With this approach, students learn sensor fundamentals through practical experience, which they can then draw from anytime they need to collect data from any sensor. To further explore this approach, download the free courseware linked on this page.